Adding fractions. Some really useful techniques here, as well as learning to add fractions. Fractions and pies. This is a half, and this is half a pie. Quite useful for showing what a half is. This is a quarter, and this is a quarter of a pie. This is the story of fractions and pies. How do we add fractions? Suppose we want to add two fractions, a half and a quarter. So this is a half of a pie, and this is a quarter of a pie. This was extremely useful because we will continue our sum, but we know that half a pie, if we draw a line across here, is 2/4. We can see that. So I'll write 2/4 up here. We're still adding the sum, so it's still plus a quarter, and down below it's a plus a quarter. But we can see here we've got a quarter, a quarter, and a quarter. So that gives us 3/4. And of course, mathematically, we've got 3/4. So the pie has demonstrated the maths. A half plus a quarter is equal to 3/4. More importantly, we converted everything to the same type of fraction, a quarter. 2/4 here, 1/4 here. And so we have the rule, when adding similar fractions, we just add up the tops. Well, they're called numerators. When we're adding fractions which are both quarters, we can just add up the numbers along the top to get 3/4. Suppose we want to add two tricky fractions. I'm going to assume you know that a half and a quarter weren't that tricky. Oh dear, a half and a third. So there's a half and there's a third. Now we can't turn a half into several thirds, and we can't turn a third into several halves. They are quite distinct, but I have got a cutter. And this cutter would be pushed down into the pie and will slice it up into 6 parts, each part being 1/6. So let's apply the cutter in a strange order. We'll apply it to this one first, and we end up with the half being cut into 3/6. Useful. And the third makes up 2/6. Great. So we know that our half and our third have become a 3/6 plus 2/6. So again, we can add up the pie, and we know 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 5/6, and that's 5/6. Again, the pie and the cutter have done the maths for us, and the maths has been trailing along. We've shown that a half is equal to 3/6 and a third is equal to 2/6, but we've had to do it using a pie, which is limiting in an exam circumstance. So, converting to common fractions. Can we do this mathematically? Let's have a look at what we know. A half is equal to 3/6. Interestingly, that's 1 times 3 and 2 times 3. We know that because of the slices of the pie. And a third is equal to 2/6. And again, we've doubled the top and we've doubled the bottom. Again, proven by the pie. So if we take a half, with a funny sort of extended line here, and multiply the top by 3 and the bottom by 3, we end up with 3/6. We've shown that if we multiply the top by 3 and the bottom by 3, the fraction of a half remains the same. It's the same value. And again, multiply the top by 2 and the bottom by 2, and a third remains a third, but it's now 2/6. This is a demonstration of the rule that 6 is a multiple of both 2 and 3. And that's what we want to do. If we add a fraction, we add using a fraction that is a multiple of both bottoms, bottom being a technical term for denominator. So we take our 2 and we want to add a third. We need to find something that's common to them, and 6 is common to both of them. This is a major rule. Multiply the top and bottom of a fraction by the same number, and the value of the fraction does not change. So when we're going to sixths, we multiply 2 by 3. We must multiply the top by 3, and this remains the same value as this. The same over here. We multiply 3 by 2 to get 6, and we multiply 1 by 2 to get 2. This has the same value as a third. And that's what we use. So, adding two very different fractions without any pies. This is when it becomes a bit more difficult. We're just using mathematics now. Ooh, okay, so we need to think. What do we look at? We don't think about 3s and 4s. No, they're not important. These are important. 8 and 10. This is what this question's all about. We need to get a common fraction which 8s and 10s can be converted into. We need to find the lowest common multiple of 8 and 10, which is 40. That's 5 8s and 4 10s. We can use any multiple, but the lowest common multiple is the easiest. It keeps the numbers more simple. So we're going to go to 40ths. What do we do to this one? Well, we multiply top and bottom by 5. 8 times 5 is going to be 40. And this one we're converting to 40ths. So we multiply the top and the bottom by 4. So we have 4 times 4 and 10 times 4. You can see that 8 times 5 is 40, 10 times 4 is 40. So everything is going to be over 40. Here we have 3 times 5, 15 over 40. And over here we have 4 times 4, 16 over 40. And now we've got 40ths. Not an easy word to say that. And all we need to do is add 15 and 16. We have 31 40ths. That is something that you really can't guess at when you see this. I have no idea how that's going to turn out, but I do know it's going to be 40ths. If this was an easy number like 8, I could simplify, but 31 is not going to simplify with 40. So, question done. What's the process? As with lots of maths, have a little think. What's the most important thing? Well, what are we doing? We're fraction adding or subtracting. Find the common fractions. Find the common multiple, the lowest common multiple, the common multiple, which so you can convert both of your fractions to the same type of fraction, and then convert them, and then complete the addition or subtraction. Subtraction works in a very similar way. So, my favourite slide, pause and practice. It's your opportunity to show your skills. What is 1/3 plus 2/5? I hope you've frozen your screen and completed the question. Best of luck if you've tried. Here is my version of the answer. Think. Fraction addition. What do I need to do? I need to get these to be the same type of fraction. Right. 3 and 5, both primes. Lowest common multiple is 3 times 5, 15. 3 and 5 I look at. Lowest common multiple, 3 and 5, is 15. I've got to convert this to 15ths. So I'm going to multiply by 5. Top and bottom by 5. 1 and 3 times 5. And this one I'm going to multiply by 3 to get 5 up to 15. So I go to multiply by 3. So 3 and 5, that's 15. 1 times 5 is 5. Thank you very much. Here again, 15ths plus 6 over 15. 2 and 3 times 3 is 6. I've now got 5 15ths and 6 15ths. It's like a tongue twister, this question. 5 15ths and 6 15ths. Shell seashores by the seashore. Right, and that's just got to add these two up now. That's 11 over 15. Hard one to check, really, because to be quite honest with you, these fractions don't mean a great deal to me. That's about 1/3, that's about 1/3. Add them together, 2/3, and that's about 2/3, isn't it? 10 over 15 is 2/3. Probably right. We've taken a tricky question and we've made it possible, I suppose. Anyway, if you've enjoyed this, or even if you haven't, why not subscribe?